Hello, once. So we have another AIME problem. So this was number 8. So triples ABC D, like BC is perpendicular to the base AB and CD, and then diagonals are perpendicular as well. So we want to find the BC square. So let's get started with some figure, but it says the leg is perpendicular to two sides. So which is why we do expect to get 90 degrees for one part. So like if I start with this, right, something like this. Like I can say this is B and this is C. That means this has to be AB and then this has to be like CD. And we are told AB is root 11, so which will be this guy based on my labeling, and then AD will be this guy. This guy is way bigger than this one because this is around like 3 point something, but this is like way bigger value. Maybe I should make this AB slightly smaller than that. So which is why I'm gonna do that. So it does something look like this. Okay, it didn't really work well. Okay, so I think something like this. So if I make this is 90, and then this is 90, so this is B, this is C, and then this is A, and this is D. So this is root 11, and this is 1001 under square root. Okay, so now we know, let's say this is H, which we are interested, and we need the diagonals to be perpendicular as well. Okay, so this does not really look like perpendicular, but this looks good. If I drag this A to the left a bit more, so that will be actually good looking. Okay, so now we need to know the H, but at the same time, we need to relate these two numbers to this H somehow, so we can at least get something out of it. But another thing we know, we have a parallel line. So this is a trapezoid, so these are parallel. Now we have a lot of 90s, which is a good indicator to hunt for similar triangles. So if I label the angles, that might be useful. So I'm going to say, let's say the angle right here is this measure. So this angle has to be same as this guy. Okay, I'm going to label that way. So this one, whatever angle right here, I'm going to use different colors. So these two add up to 90 degrees. So you can say alpha and beta, but I'm going to just color it. So this blue angle is the same as the angle right here because they are alternate interior as well. Okay. And the blue and purple add up to 90 because this is 90. And this is purple and then this is something. And then these two also given 90. So which is why we can easily say this has to be the same as blue angle as well. And similarly, so this has to be purple, but if we need to do so. So we have a lot of like angles are equal, so which is why we have the triangles are similar. So if that's the case, we can easily write the ratios. So let's go ahead and do that. Like at the same time, I need to use the triangle that have some information. So I kind of know this space, but I don't know this space. I'm gonna call this is X. And I like to find a triangle that has something or that is what I'm looking for. So which means I need to get a triangle that involves H for sure right, when I write the similarity. So maybe I can use ABC because this side is known and then this side is what we are interested. So I'd like to compare this triangle with another one that I have some information about it. So like if I start with the purple on this ABC, that's opposite to H, the purple angle maybe in this larger one, BCD, I can use that one or I can use this one, but I think I'm going to use BCD because BCD also has H as a one side. So, but in BCD, since the C is 90, this is blue, which means this angle right here is the purple angle. Maybe I should show that. So this is also a purple angle. So now we are ready to write the ratio. So the H was the side opposite to the purple angle in ABC. In the BCD, purple angle is opposite to X. So that's my ratio of the corresponding sides. Okay, so now we have that. in the ABC, maybe I can use AB now, which is the angle the side opposite to the blue angle, which is root 11. The blue angle in BCD is opposite to H, so that should be divided by H. So then H squared is equal to x root 11. Okay, this is an equation in terms of two variables, which is somehow useful because at least we have an equation instead of having nothing. But if I have another equation in terms of the same two variable, then I'm gonna get something out of it. So when you look at the figures, so maybe we can use some other similar triangles to get another equation in terms of the same variable. But at the same time, if I really wanna do something else, like I can extend this one, so I can make a right triangle because I need to use that 1001. So I just want to make a right triangle that includes that. So I'll just extend BA and then I'll make a perpendicular from D to that extension. So we'll make a right triangle. So since BC is H, so that's also H. And then A to this point was X. So this is root 11. So that part should be X minus root 11. Okay, so now we can use the Pythagorean, so that should be x minus root 11 squared plus h squared equals square root of the hypotenuse, which is good because no radical involved now. So let's expand this guy. So that should be x squared minus 2x root 11 plus 11 plus h squared is equal to 1001. So we know h like is what we are interested, so we don't like to get x at all. So if possible, we need to remove it. But there is a x squared right here. So we probably remove the, like, we cannot, like, I can replace x root 11 with h, which will make this guy negative 2h, but still we have x squared, so maybe I should find the x first. So if I make the a square and replace right here, so you will get x squared, or I can even change this guy, right? I can take the x as a squared over root 11 and then replace it. Actually, let's do that way, so that might be useful. So otherwise, I need to get x first, which is probably possible as well. But if I do that way, so that x is a squared over 11, so that means h squared over root 11 is my x. So you square that minus 2 times. So this part, x root 11, is the same as h squared. So that should be h squared. And then plus h squared. And I can subtract 11 from both sides. So you got 990. So let's simplify this a bit. When you square this guy, you got h to the 4th power over 11 minus 2h squared minus, this will be minus h squared equals 990. And now we can multiply both sides by 11. So that should be h to the 4th minus 11 h squared minus 11 times 990 is equal to 0. So like you can do the substitution now for a squared to make this a quadratic and then go from there. So if I make the a squared as, let's say, y, so let's do a squared equals y, then you end up getting y squared minus 11y minus this, so 11 times 990. So I don't want to multiply because if I can factor this, I will try factoring. So I like to find two numbers that has a difference of 11. When I multiply, I should be getting negative 11 times this number. So I can try maybe like 9, right? And then I can take the 9, 11, and 10. So I can split those to see if there is way to. So since we want to get 110, maybe I can go with 9 and 11, which is 99. So if I take 9 out of this, that will be another 11 times 10, which is 110. So I think difference between these two is 11, so which is good. So then this is factorable. So that will be y minus 110 times y plus 99 has to be 0. So from here, so you get y equals 110 and then y equals negative 99. Since, we said y is h squared, so h squared cannot be negative, so we can cross this. And then h squared is 110, which is what they are asking us to get, b squared. So that will be our answer, which is 110. So that is my final answer. So we just use a similar triangle as well as a bit Pythag. So otherwise, it wasn't really as challenging. It's just seeing that's still our one of the good tools. Anyway, so I'll see you in the next video.